Good morning, everybody. Welcome to the Hackathon, the Cancer Biomedical Data Hackathon AI Bootcamp. And Dr. Ryan Melvin will be presenting. He is Assistant Professor of Anesthesiology at UAB. And there's going to be a hands-on presentation and a lot of exercises for helping you learn about AI and deep learning, and also get ready for the upcoming hackathon. So Dr. Melvin.
Awesome, thanks, Amy. So hopefully, ideally, you got to do some of the pre-work that was sent out, but I know that's probably unlikely that everyone or maybe even most people were able to do it. So what we'll start off with is making sure that you have the technology for what is absolutely necessary. And hopefully in the next 15 minutes, we can at least get everybody on what's called Google Colab. So Google Colab, I'm going to switch tabs here in Safari, is essentially a IPython notebook in on Google Drive. That is the basics of it. And if I open up this file here, I'll share these files in just a second, but just so you can look without being distracted by trying to do things. This is a Google Colab notebook. And so you see I have text up here. And this particular notebook I took from the PyCaret tutorials. We'll get into what PyCaret is, and I've modified it slightly. But then there are cells here that have code, and I can run the code. So this is Python, and this would be running on one of Google's machines. And in fact, if I wanted, I could ask for a GPU or a TPU, a tensor processing unit, to be able to run more complicated machine learning models. So again, just showing you Google Colab. It's an IPython notebook in the sky. And you can essentially get a free GPU or tensor processing unit to use on your work. Now, obviously, since we're at a institution that has a hospital attached, if you're using any non-public data, you can't use Google Colab. You're going to have to use UAB Chiha or your local machine. But if you're using public data for any project, Google Colab is great. It's a free machine learning machine in the sky. I recently discovered it. I think it's been out there for a while, but I was very excited to find, hey, there's just a free GPU out there for anybody who wants to use it. I think technically it's a Tesla K90 GPU, so it's an older one and limited in memory, but it can do quite a bit. I think K90 is a real NVIDIA model. Maybe I just made that up. Anyway, it's a slower GPU, but it's there and it's free. So if you want to use Google Colab, you do really need a Google Drive account. So here inside my Google Drive, inside this particular folder that I'll share with you in a second, if you just open up Google Drive, you can check if you have Google Colab. So from any folder in Google Drive, and again, you will need a Google account. So I'm sorry if you are anti-Google. You can certainly watch this presentation without violating the principles, but you will have to sign up for at least a Google Drive account if you want to follow along with the hands-on demos. So first off, once you're in Google Drive, so if you're following along, make sure you go to Google Drive, trying to make sure everybody has a moment to get there. It's just, hold on, sorry, my dog's going a little crazy. It's just drive.google.com. So if you'll go to drive.google.com and sign in, you'll have a button that says New. And over here under New, if I go down to More, I have Google Collaboratory. So I'll pause here and let everybody catch up. You may not see Google Collaboratory right here. And if you don't, there's another step we'll take in just a second. If you do have Google Collaboratory, go ahead and click it and let it start up. So I'm going to pause mainly to make sure we're all following along. Will you just put in the chat, do you have Google Collaboratory in the More panel here? So just say yes or no in the chat. See, one person's responded so far, 2 people. So we're just putting yes or no in the chat. Do I see Google Collaboratory right here? 4 people have responded. Okay, mix of yes and no's. All right, thanks to everybody who's responded. That's good enough for me to know what we need to do. Okay, if you don't see Google Collaboratory right here, you're going to click Connect More Apps, and this screen will look a little different for you. I'm going to try to do as much as I can to show you what's happening. And up here in Apps, if you just start typing Collab, and I think it's 2 L's, maybe it's 1 L. 1 L. Okay, so if you type Collab, you'll get a result that looks like this, and mine says installed. You should see a button that gives you the option to install, or I think you may have to click it, and then, okay, and then the button will probably be here for you. So I'm gonna go through that whole process one more time of finding this, just so everybody can see. So from any place in my Google Drive, doesn't really matter where, I'm gonna click New, More. If I see Google Collaboratory here, I'll go ahead and click it. If not, I'll click Connect More Apps. And then up here in the search, I will type COLAB, enter. Right? And then this will show up, Collaboratory. I'm going to click Collaboratory. And then you should see a button that says Install. So if your button says Uninstall, you've already got it. If your button says Install, you should click the Install button. Okay, just going to pause, let everybody catch up. Okay, so I did set aside 20 minutes just to make sure this is working. So right now what I'd like to do is, if you have a Google Drive account, I can't help you if you don't, but if you have a Google Drive account and you're just like, I'm totally lost, say so now and we will figure it out. We'll take the next 5 minutes to try to figure it out. So anybody need help? Anybody confused so far? Just don't be shy, say so in the chat, we'll help you. Worst case scenario, we'll share your screen and we'll do it on your computer. All right, I'm gonna wait 10 seconds. If you are totally confused and need help, you have 10 seconds to say so. Okay, we're gonna move on then. So the next part of the setup is I'm going to share this folder that I have here with you, and then we're going to use this folder for all but the last about 20 minutes. In the last 20 minutes, we'll switch over to Chiha. I did this in Google Colab because I am sure I can get everybody working in Google Colab today. If there are problems with Chiha, that might require more tech support on the Chiha side. So we're going to use Google Colab for most of this demo. All right, I'm going to copy this link and put this in chat. And this will be a read-only link. So if you click the link that I just put in chat, it will take you to a folder that looks like this. And again, at least on the initial setup and troubleshooting, we're ahead of time. So if you can't access this folder or anything goes wrong, just say so in the chat and we'll fix it together. Okay, I got at least one. I can't access it. Let me see what my access settings are. Anyone on the internet with this link can view. Okay. So what I'm going to do just to test this is I'm going to open up a private window and make sure I can get to it from the private window. Okay, I am able to access it from the private window. Shows code, not folder view. Oh, okay, so possibly I sent the wrong link. Gotcha. All right, So I'm going to double check my own link. All right, apologies. I'm sending a new link. And that should show you a folder containing, let's see, 10 files. Okay, sorry about that. So the most recent link I sent out shows you a folder. All right, getting lots of positive affirmation that it's working. Is there anyone it's not working for? Okay. Perfect. All right. I am going to open up binary classification tutorial level beginner. So when sorted by name, looks like, is it ascending, descending? It'll either be your top or bottom option. So if you sort by name with the arrow pointed up, it'll be your top option. If you sort by name with the arrow pointed down, it'll be your bottom option. Okay. And I will say I am on a laptop because I'm traveling. And so I'm trying to watch the chat as much as possible. But if someone asks a question or has trouble and you know the answer, feel free to tell them because I will probably not be able to watch the chat as much as I would like to. This tutorial is taken directly from the PyCaret tutorials, which you can find here. There are lots more than just this one, or in fact, the 3 that I'll show you today. They have several. I'll just click the link. So if you have something you want to do and it matches up with one of these names in their tutorials, then it is very much a almost plug and play experience. You just point the software I'm going to show you today at your data instead of the example data. And also, just to share, within the PyCaret GitHub, so I just went up one level from the tutorials, they also have several examples. So even if there's not a tutorial that sort of carefully walks you through something, there are PyCaret examples that if you know what you want to do, say for some reason, I really want to train a light GBM model on a GPU. Well, luckily for you, there's a PyCaret example of that here in their GitHub. Okay, but that's sort of tangential. So going back to the tutorial, this is where we should all be, the binary classification tutorial level beginner. I've added some notes in here, but again, generally I just took this from PyCaret. Part of this is so if you have trouble and I'm not able to help you, you're very likely to find an answer in their GitHub issues, on forums, or in the PyCaret documentation. So first off, I've said the word PyCaret several times. What is that? It is almost auto machine learning, almost automatic machine learning. PyCaret can be pointed at a data set. You tell it what your targets are, the thing you want to try to learn how to predict. And PyCaret will do a pretty good job without you specifying much else at building some good models. It is very powerful, I think, for beginners because PyCaret gives you lots of information as you go along, which we're going to see in this tutorial. So if you are new to machine learning, you don't know what all the words mean, PyCaret is almost going to present you with like a vocabulary list. And you could go to Wikipedia and you could look up the words it's presenting you with and learn more. And also, as you learn more, PyCaret will let you change a lot of options. But to start, you don't really have to. So you can get started with machine learning, sort of throwing PyCaret at your data sets, letting it tune your models, and you're going to do a pretty good job. But if you know more, or if you start to learn more, all of the things that PyCaret does automatically behind the scenes can be automatically tuned. So that's why I chose PyCaret for this tutorial, because it's sort of adaptable to whatever level you're at. Okay, so to get started, we will need to install PyCaret. So if you look in section 1.1, it is not built into Google Colab. So what we'll do is, since this is your first time, if you go down to the first code cell that should say #, or if we must, hashtag, exclamation point, pip install PyCaret, and then a couple other things. So if this is your first time running PyCaret in Google Colab, which is probably true for everybody, you'll just uncomment this. So now I just deleted the pound or hashtag, and I'm just going to run this cell by clicking the run button. And this is going to take a minute because it is on Google's machine actually installing the PyCaret software. Okay. While it does that, I'll give you just a little bit of info on what this first demo is going to be. We're going to do a binary classification task. So that just means that I am trying to predict one of two possible answers for a bunch of observations. And this particular task will be on the default of credit card clients data set. So from a whole bunch of people who have credit cards, some of them defaulted or didn't pay their balance for a specified amount of time. They defaulted on their credit card loan. The bank would really like to be able to predict who in the future will pay their balance and who will default. And so we're actually going to use this data set. I think this is from UC Irvine. Yeah, UC Irvine put together this data set. If you want to look at it and you want to know more about the data in it, under section 4.0 in this tutorial, there's a link there to the data dictionary. Let's see how we're doing. Okay, so I have noticed on Google Colab that this will happen. You'll get what looks like an error because it says the word error. As long as you got this line that says Colab mode enabled, we're good to go. And I have tested this out. It was frustrating to me. This error comes up. Essentially, there's already a package installed and Google Colab is not letting you install, it looks like older version of it. But as long as you get to this message that says Colab mode enabled, we're good to go. So just to make sure I didn't go too fast and lose anybody. On the cell, I uncommented this first line. I just removed the # or hashtag that said pip install PyCaret. These other two lines were already ready to go, and I just hit run. Just in case we have to do this again, I'm going to recomment that line. If we have to run this again, I don't need to install PyCaret again for this session. If you close out your Google Colab session and you come back later, you may find that you have to install PyCaret again. So if Google actually closed down the machine you were working on, or if you went in, you can actually, I think it's under runtime, you can look at the sessions you're running. If you actually terminate this session and you open this file again, you will need to pip install PyCaret again. Your Google Colab environment is not persistent, is the way to say that. So that was just to show you that I have one session running. If I were to terminate that session, I would need to come back and do this line again. Okay. Not seeing any objections from the chat or questions showing up. So hopefully you ran the cell. And again, even if it showed an error, the only thing we're looking for is Colab mode enabled. As long as you get that, you're going to be fine. All right, moving on. So I have here, again, I say I, but really a lot of this copied from the PyCaret tutorials. So descriptions of the data set. And then I want to unhide all my cells. I guess people like this for presentation mode, but if you go to view, expand sections, okay, all of those hidden code cells will now become shown. Or there was like a little bracket symbol here you can click if they're hidden for you to get them back. But to unhide all of them, again, that was just view, expand sections, which is now grayed out for me. Okay. So first off, we're just going to pull in the sample data set from PyCaret. Later, we'll do an example with a more real-world data set. But this is just built into PyCaret. So we'll import their dataset submodule or subpackage and use the method getData to get our credit data set. All right, and then here are the first few lines of the data set. So you can see demographic information, how much they paid on each bill, and then over on the far right, default. Okay. See a couple people in the chat got the error message that I got. Again, as long as you get to collab mode enabled, we're good to go. All right. So I've loaded in the data set, and now I just want to see the shape of the data set. So we have 24 features and 24,000 observations. So 24 columns and 24,000 people or credit card accounts that we have those columns for. Okay, the next part is a little bit more academic, I suppose. So what I'm going to do is set aside 5% of the data to use as like a formal validation set. So once we're done and we've picked what we think our best model is to predict who will pay back their credit card and who will not, we'll use this 5% that I have set aside, not looked at. We're not going to have what's that called post-selection inference bias because we've set aside this 5%. We're truly going to check this 5% we've never ever looked at, we promise, when we tell our reviewers at the journal. So I am setting aside 1,200 observations that we're not going to look at until the very end when we want to judge our model. I think if you're used to Python, the next part gets a little bit confusing. So PyCaret uses this metaphor of environment, and we're going to set up our environment. Oops, I didn't mean to take that out of text mode. Take that out of display mode. Okay. So we're going to set up our environment, and if you have used Python before but not PyCaret, and you see those words, you're expecting certain things. You're expecting me to like tell you a whole bunch of things to pip install, or to give you a YAML file that you can point Anaconda at to install a bunch of packages. But what this really means is like an environment for your experiment. So we're going to set up a PyCaret session. This really, I think a better word would be session. So we're going to set up a session in PyCaret, but their metaphor is environment. They say we're going to use an environment. And there's some details here, but I want to jump straight into this because it's really going to explain as it goes what we're doing. So we're going to do a classification model. I'm just going to import everything from the PyCaret subpackage classification, grab all of that. And then here is the important bit. So let's actually just break this out a little bit so we can talk about this line by line. Okay. Oh yeah, so good question. How are we doing this in your Google Drive folder? Okay, so at the moment, you're actually doing this in a collaboratory session. Nothing you're doing is going to be stored in my folder. You're just running code. And as far as like temporary files being stored or output files being stored, they are stored inside your collaboratory session. So if you click here, the little file and icon, the Google file system gets a little muddled here. So I could access my Google Drive directly, and we'll talk about that in a second. But really what happened when I opened up this collaboratory folder is Google launched a virtual machine for me, and we're using the storage on that virtual machine. So I get why that would seem a little bit weird. It's not analogous to like Google Sheets or Google Presentations or Google Docs, where if you were to change it, it would change what's also on my drive. Rather, all the changes you're making are happening inside this virtual machine that Google has launched for you. That's a good question, Amy. Thanks for pointing that And I'll also say, if you really want this to just be happening in your own Google Drive, you can save a copy to your Google Drive. You can also do that at the folder level. You can save a whole copy of the folder I gave you to your Google Drive. Good questions. Okay, so I imported all of the methods from classification inside PyCaret, and we're going to do this setup. So this is what it means by setting up an environment. This is where I set up a PyCaret environment. So I have my data. And if you're used to scikit-learn, you're probably thinking, well, shouldn't we have split out our X and Y and our train and test? PyCaret's going to do all of that for us by taking in our full data set, including our response column. So our response column here is whether you defaulted on your credit card loan. And that will be our target. So we'll say setup, data is our full data set, target is our default column. So this is just the name of your response or target column as a string. And then session ID. This one seemed a little weird to me when I first started working with PyCaret. So once you have set this up, PyCaret's going to have an environment object in memory, and everything we do will act on that object. And if you're used to Python, the closest package I've used is matplotlib, where you have a plot that's an object in memory, and rarely do you actually like address that exact object. You just sort of execute methods, and you know that matplotlib is acting on that object. That might be too technical for lots of folks, but if you're sort of used to Python object-orientedness, it gets a little weird here. So we're not going to have to act on this object that we've named here. Rather, we're starting up a PyCaret session, and PyCaret is going to assume everything we're doing is acting on the same session. The only things you actually have to have here are data and target. You don't even have to specify a session ID. It will set one up for you by default. Oops, I did not mean to make the chat that big on my screen. Okay, sorry, just adjusting where some of the Zoom things are so I can do this next part a little bit better. So if I run this cell where I'm setting up my environment, again, that's the PyCaret metaphor, is we're doing an environment. The first thing that's going to happen is it looks like it's sort of stuck, but it's not. So notice it's given you a message. It says, we've inferred these data types automatically. And if you were doing this for real, you would want to make sure that all of them were exactly correct. If they are correct, let's see what it'll tell me to do. If they are correct, press enter. So I've got my box here where I could type quit if they were wrong, but they're correct. I'll hit enter. And now it will continue running. I do not want words. OK. So again, I hit run. It looked like it was stuck. It just kept spinning. But it was asking me a question. Were all of the data types that it automatically inferred correct? Were the things it thought were numeric actually numeric? And were the things it thought were categorical actually categorical? OK, so this is my favorite part of PyCaret. Because if I start looking through this big list of information it just provided me, things get really deep here in terms of how technical I can get. So obviously I've got some numeric features. These are numbers and continuous. I have some categorical features, so these are discrete. It did not detect any ordinal features. That would mean like ASA status for surgery. So 2 is higher than 1, and 3 is higher than 2. Those would be ordered or ordinal features. But I just have categories and numeric features. If you want to start doing what's called shuffling. So again, this is why I like PyCaret. I don't have to know what these words are, but if I do know what the words are, then I can change them. I can also go look this up. So I may not know what stratified k-fold is, but it's presented the word to me here for me to go look up and change if I want to. I may not know what imputation is, but it's presented the word here for me to go look up. And as we go along, you can actually change these. So any of these things that PyCaret is presenting to you, do we want to do transformations? Do we want to use PCA maybe for feature reduction? Do we want to have iterative imputation? Do we want to normalize our data? All of this I can adjust. How do I want to fix imbalanced data? Here we're going to use what's called smote. Again, I may not know what smote is, but PyCaret's telling me it's about to do it. So I could just go look it up. What I want to do now is take a moment for you to look at everything PyCaret is presenting to you when you run the cell. And again, you have to run the cell, and then it's going to say, if the data types are correct, hit enter. You have to hit enter. Then it will present you with this long list. And inside the Google Doc we're working, I have 4 questions for you. So take a moment, look at this information PyCaret is presenting to you, and answer these questions in the chat. Preferably all at once. So just 1, 2, 3, 4, and you'll have 2 yes or no questions and then 2 just number questions. So let's just take maybe 2 minutes, look at all the information PyCaret's giving you, and try to answer these questions just to make sure everybody's following along. Okay, so a couple people are having trouble seeing all of the code. If you're not seeing all of the lines of code that you think you should, you may have to go to View, Expand Sections. So I'll even show you what the, I guess, wrong way looks like. So maybe if your code looks like this, you can click to expand whatever was hidden, expanding things that are hidden, or to do it all at once, View, Expand Sections. Okay, sorry, I'm just scrolling back to where we are on these questions. All right, Christopher is playing along. Thanks, Christopher. So, David's playing along too. Excellent. Ooh, so David, I would ask you to refine 3 and 4. So the question is, how many samples? So think about that question for just a second and see what it might, what PyCaret is telling you about samples. Right, 1 more minute. Thanks to the 2 people who've played along so far. So you're just answering these 4 quiz questions in the chat. Thanks, Peter, for playing along as well. Yep, David, you got it that time. Okay, so thanks to, I think that was 5 people who played along. So special bonus points that you can't cash in anywhere, but given to you. Oh, 6 people, thanks, Dee, playing along as well. Okay, I put a link here to the PyCaret documentation for the classification API. Oh, a couple people catching up, playing the game as well. So if I click this, within classification, there are all kinds of options you can set. So PyCaret just showed them to us as a table. And here are the very basic details. And when you read these, they really are intended, like these details were written by software engineers. They don't tell you anything if you don't already know what the words mean. But you can at least come in here and know what the thing is you want to set. So for example, iterative imputation. So if I want to change my imputation type from simple to iterative, again, you would go look up these words. So simple, I think in PyCaret just means use the average for numbers and the least common for categories. But if I actually wanted to do something more like, let's predict all the missing features one at a time, start with all the data I have and then predict the least missing and then the next least missing and so forth, I could change my imputation type. So I'm going to pretend like we're going to do that. I just copied the feature name. What I would do. Oh, I see. It's because I'm switching between Windows and Mac a bunch today. Imputation type equals, and I could change it to iterative. And now my imputation type would be iterative. And if I ran this, I would actually see that change in the table of information that PyCaret just presented me. So again, PyCaret's laying out sort of a plan of what it's going to do in this quote environment that we set up. And then when we're ready, we can run the plan. So that's actually the next step. And just to prevent confusion, I'll take this out. I'm not going to do iterative. I want to pause. We're ahead of time. So I'm going to share one trick that I've learned from programming and data science and sharing my code with other people. If you have multiple properties you need to set for a method like this in Python, I think it's very tempting and very standard to, one, either just have it all in one line, like I did originally, like I said, very tempting, or two, to break your lines after the commas. I see people doing this a lot, and this used to be what I did too. But let me share with you what I think is like a life-changing tip if you don't do it already. Break your lines before the commas. Because let's say, I decided I wanted to change my imputation type to iterative. Well, later I don't want to do that anymore. So do I delete the line? If my line was broken after the comma, then I've got to put like a comment up here before the comma and a comment here. But because I've broken my lines before the commas, I can actually just comment out all that at once. And notice, I don't have to deal with adding back in or taking back out the comma. I can just comment out that whole line. And because I've also broken my line right before my open or my closed parentheses, real easy, right? I don't have to move this parenthesis around. Someone showed me that a couple of years ago, and it's changed my life. So I think that tip, if you've never done that before, worth the price of admission today. All right, moving on. So we've set up our environment. We haven't actually trained any models yet. Details in here on what all some of the important words mean. And then again, I've linked you to the documentation. But let's just scroll down to section 7, where we're going to create this best model object by just running the method compare models. And it really seems like we're supposed to type something here, but again, we have this PyCaret session or environment set up, and everything is acting on that one environment. So I'll just go ahead and hit run. And what's going to happen now is with default settings, so there's really no magic yet, PyCaret is doing stratified 10-fold cross-validation on, I think it's 11 model types. We'll see in just a second. I think there were 11 by default. And it's just going to tell me metrics on how well each model did. Again, this is one of the reasons why I'm showing you PyCaret as the way to train machine learning models. Because if you don't know what you're doing yet, PyCaret is showing you a whole bunch of words that you can now go look up on Wikipedia or Google or ask your friend about. Yes, PyCaret is doing a lot behind the scenes, but it's not hiding any of it like some of the other AutoML packages do. Showing you all this information, you can go look it up, you can ask somebody about it, and you can learn a lot. And as you learn more, you'll stop letting PyCaret do things for you. So just scrolling back up to this section, I'm not going to change anything. But I let PyCaret set, what, probably 57 things for me because I specified 2 or 3. Zero-based indexing. So I let it set 58 things for me. I could have set any of these features, any of these parameters, that's the word I've been struggling to find, any of these parameters for that method or function. I let it do it for me, but as I learn more, I can start to adjust these. I can tell PyCaret, I want to change the imputation type. That was my example up here, where I changed my imputation type. But I can adjust all of these settings, or I can let PyCaret pick for me, and honestly, it does a pretty good job. So as you start looking up the settings it's setting for you, they're actually pretty standard. Nobody's really going to get mad if those are what you report in the end. So the problem with a live coding demo, right, especially doing this on Google Colab, if lots of people are doing this, I bet they gave me a little slower machine today. Okay, so we'll pretend it's finished, and then someone can count and tell me whether it was right when it's done, if it was 11. We've got several models that PyCaret has tried, and it's going to sort them by best performance. I think by default, it's accuracy, who perform best by accuracy. And so here, a ridge classifier, so that's a type of logistic regression, is getting the best accuracy on the credit models. It sure seems like something went wrong, though, with that AUC being 0. So I would be suspicious. I might run this again. I might set a different random state and run this again. I'm not sure what happened there. Anyway, one of the ones that maybe don't have a 0 AUC, like linear discriminant analysis. So here was our accuracy. We got 82% of the responses correct, but it looks like maybe we're just guessing the biggest class because we've got kind of poor recall and a poor F1 score. So I like looking at F1. It's the balance of, oh my gosh, I haven't enough coffee today, with sensitivity and specificity. So basically, how good are you at true positives? How good are you at true negatives? And it's giving you a balanced score based on those two things. So accuracy, you know, if I have 90% of people defaulting on their loans, I could just guess everyone defaults on their loans and be 90% correct. But F1 tries to balance out that true positive, true positive, true negative scores. So you can figure out, how is my model doing in both directions? And honestly, none of these are doing super great. Anyway, once it's done, we can see what the best, quote, best model is with default settings. And again, I like PyCaret because if you don't know what the words mean, you can just go look them up. It's not hiding anything from you. The next function we want to talk about is create model. So again, sometimes I get a little messed up by the PyCaret words. Didn't I just like create 1, 2, 3, 4, 5, 6, 7, oh, I was off 8, 9, 10, 11, 12, 13 models. Did I just create 13 models? No, you compared 13 models based on their default settings. But now let's actually create a model. So PyCaret will have a model for us in memory. And you can get it to list all of the possible models for whatever you're doing. So here we imported everything from classification. So these are all the classification models that I can use. And just for the purposes of this demo, I'm going to create a decision tree classifier. So the way to do that is I'm going to give my object a name, so here DT, and I'm going to run create model, and then I'll go back up here and find decision tree classifier in this table of models from the models method. So this just gives you a list of all the models PyCaret can make for whatever you're doing. Decision tree classifier, and PyCaret calls that DT. And just in case you're interested, that is indeed, as you might expect, just coming straight from scikit-learn. So we're just getting our decision tree classifier from scikit-learn, but PyCaret's going to handle all the details. So DT, create model, decision tree, or DT, whatever it says in this table up here. I run it. Oh, and someone did ask, I'm curious why our accuracies are exactly the same. Did we cheat? If I remember correctly, sorry, I'm going to scroll back up to answer this question. When you set a session ID, I think you're also setting a random state. I think that's what's going on, though you could go look in the PyCaret documentation and make sure I've got that right. But I think what's going on is because we both use the same session ID, all of our random number generation is going to be the same. So it's a good question. You could test that out by just changing the session ID. Maybe we just got very lucky, I guess would be the other answer. All right. So I created a model, and that went fast. Sorry, let me just do it again so we can all watch that happen. So this is going to do 10-fold cross-validation, stratified cross-validation because of the settings that were the defaults in PyCaret. And just based on the default settings for decision trees, here's what we get. Again, for me, the kind of problems I solve, I skip straight to F1, just think like, who's doing the best on sort of balancing out positives and negatives? Nobody's doing great. But, or I guess this model isn't doing great because we just did 10, and we're looking at the average over 10 folds of cross-validation. But our accuracy is, 70%. Maybe we're, again, just guessing whatever our biggest class is. And here, when I ask it to print DT, this is really just showing me all of the default settings. Again, we'll get to tuning in just a second. I can create a nearest neighbors classifier. So this would be a supervised k neighbors classifier. And there's a question of where is randomization happening. So when we split our data into train and test, which again, at the moment, we're just accepting the PyCaret defaults. I'll scroll back and see what they were. I think PyCaret likes to do 30%. If I remember right, for playing around with this. So PyCaret split our data into a train set and a test set, and it would have selected those randomly. And so that is where one randomization is happening. Our k-neighbors classifier we just built will have random, some random seeding going on, as would our random forests and our random forest based models, like our boosted model that's in here. The ridge classifier also, I think, for choosing one of the parameters, there might be a random sample happening. So I guess the answer is a couple places. The most obvious one would be how we split our train and test data. That would have been a random split. I don't see the setting in here, but I know you can change it. I think it's 30% by default of the data is in test. And then another question, why does it look like all the code was already executed? Because I did execute all the code when I made this folder. So it's just showing you the answers I got the first time I ran them. And then you're going to get potentially different answers. All right, we'll also run the random forest. I think by now you're probably picking up on the pattern. You just go to that table, you look up what the name of the model is, and you put it here to create your models. All right, while that finishes up. So once you have run the random forest, k-neighbors, and decision tree, so the question just refers to those three, 8.1, 8.2, and 8.3. Which model with the default parameters performed best by AUC? So another quiz, play along in the chat if you're so inclined. Of the three models that we just created using default settings, which one performed the best by AUC? All right, Christopher's playing along. Thanks, Christopher. David's playing along. This is also an opportunity if you're behind on the code, running, catch up. If you're confused, have a quick question, you can ask that. And if you're completely caught up and really bored while we're letting people take this quiz, you can do the try it yourself section. Okay, had 3 people play along, so thanks for playing along, guys. And what would my answer be? So my random forest average AUC was about 0.76. That definitely beats whatever this one was, k-neighbors neighbors. Now, someone say it. Someone is being being smart about it and saying, hard to say so far. Yeah, fair. Decision tree for me was 6.1, and somebody made a ridge model. What was their ridge model? Well, my ridge model was 0. I'm not really sure what happened there, but I'm not gonna, oh, no reason to be sorry. So yeah, it looks like for me as well, random forest. And again, if we're in the same random state, that's what's going on. And if you did have a chance to try it yourself, this code may have looked like nb equals create model. I think it's nb. I'll check. So I go back up to this list of models we made, and I'm looking for naive Bayes. Indeed, naive Bayes is nb. And I'll create my naive Bayes model. Okay, so for the people who have done machine learning before and have been shouting to the screen, we're not tuning our models, what's happening, just using defaults. You're right. So now let's tune the model. So I will tune a decision tree model. And I think the important part here is that tune models method acts on a result of create model. So if you want to do this, you have to first create a model before you tune it. So if I wanted to tune a naive Bayes model, I can't just do tune model NB. I have to do create model NB and have that named something. Here I named it NB. Hopefully that's not getting confusing for folks. I could call this whatever I wanted. So naive Bayes model, whatever I wanted to call this, I could call it here, with the exception of a few Python protected words. And then once I have created a model, I can tune that model. So notice my decision tree model I called DT, and now I'm going to tune DT. Okay, yes, someone is having trouble with the setup step. So what's probably going on in your setup step is you have to hit enter when it shows you all of the data types it guessed at. So it'll give you like a little line to type in. Click that line that it gave you to type in, and it looks like a little box, and just hit enter. In fact, I can do that again real quick. So sorry, just to help someone who's having trouble in the chat. I go up here, I'll do it again with you. So you're running this line, like, oh my gosh, it's taking forever, what's going on? It's because it's asking you a question and it's waiting on your answer. So if they are correct, press enter to continue. So I'll go down here, click in the box, enter, and now it's done. Okay. So now I'm going to tune a model. I'm going to tune a decision tree model. So tune DT, tune model, decision tree. And as you might guess, there are many options related to tune model in my setup. There are many options I can set. But for now, we're just using the PyCaret defaults. Still get pretty crappy F1 scores, which makes me sad. But we now have a model that we have tuned. So we're not just using the defaults, we've actually used the data we have to tune our model. I will give more details on that in the next example. So we will get into that a little more. But now I can see what my tuned model looks like. So this will have different features than my basic one. In fact, I'm just going to add a line here and have us print what my decision tree model looked like before. So notice the default setting, for example, min samples per split. I love PyCaret because if I don't know what that means, it's showing me the word. I can go look it up. But the point is, we have a different setting than our defaults. There you go. Oh, and to answer that question, indeed, our session ID has set our random state. There we go. Okay. One of the things you can do as you start to learn more about these models, or if you already know a lot, you can specify a custom grid of parameters to search. So here, for my k-neighbors model, I really want to tune the number of neighbors parameter, and for some reason, I'm saying the right answer, or what I think is the best answer, is somewhere between 0 and 50. So try everything between 0 and 50. And indeed, using tenfold cross-validation, it will do that, and then it will report back to me. You might wonder what it's reporting back. it's reporting back the cross-validation scores for the best model. So that might have seemed a little weird even up here. These are the cross-validation scores for what it thinks is the best model. Here it's going to be by accuracy, but as you might expect, there's a setting where you can say, I want to tune something else. I don't want to tune based on accuracy. I want to tune based on F1 or AUC. And we'll do that in a second. All right, while the K neighbors model is tuning, I'll just check on questions. Why does RF have the best AUC? Gotcha. So the way that I had asked the quiz question, I intended folks to just look at 8.1, 8.2, and 8.3. But if you go back to the big table and look at all of them, that's fine too. The point was just, mainly, are you paying attention? Do you know how to read these tables? Thanks for joining us, Chris. Cool. So that is tuning. That's going to take a little while. We could let these other ones tune as well. But I, for one, am, I think, in need of a slight break. So you've got a couple options. Let's take like maybe a little behind in there. So maybe just like a 5-minute break. And if you want, if you're really bored, if you're like, I don't need a break, I'm ready to go, you can go back to the folder and open up Choose Your Own Adventure, break number 1. And there are some suggested activities if you do not actually want to take a break right now. I'd originally planned for a 15-minute break, though I think I got a little behind. So I think there will be a recording is the correct answer. But Amy would probably be the best one to give the official answer.
Yeah, it's being recorded and we will post. It may take a couple days for it to get posted, but we will post it as soon as possible.
Awesome. So let's take a 5-minute break instead of 15. And if you're like, I don't need a break, you can do one of these tasks and I will meet you back here at, let's say, I'm on Central Time at the moment, but 1:06 p.m. Eastern Time. So 1:06 p.m. Eastern Time, we'll all be back. Too far, and then, yeah, thanks, Amy. So just to recap, when we left for the break, I had left a K nearest neighbors model to tune, and I had specified this parameter number of neighbors, which again, if I don't know what that means, at least PyCaret is showing me the words that if I go Google K neighbors classifier number of neighbors, you're going to find some great articles. And that's true for all of the parameters and all of the models that PyCaret can tune for you. And now I can look at my tuned K nearest neighbors model. And I can do that for these other model types, random forest. I'm just going to skip through this because I think the pattern does, you sort of get it. You put in the name of the thing you want to tune, and it tunes it for you. Here, based on accuracy, so it's trying to optimize accuracy. Okay. So let's skip those quizzes because I do want us to get to a place of running some real world examples. Once you have a model, you can use the plot model command to do some common machine learning model plots. So in this case, AUC. This is just a binary classification task. So I think this will probably look a little overcomplicated. Sorry, I'm just looking to see where we got held up. Random forest is still running. Okay. So I can plot my AUC, and I won't rerun these knowing that it's going to take a minute. I can plot my precision recall curve. I can plot my feature importances. So here it looks like, I don't remember the exact details, but whether you paid your first bill on time is the best predictor of whether you default on your credit card. So if you paid your first bill, you are less likely to default, is I believe what that's telling me. Or sorry, that is one of the most important feature in determining in our random forest model whether you will default. These aren't telling me which direction, I don't think. I'd have to go back and look. This is all an absolute value. Okay, did this finish? No. I promise we would get an AUC plot. I can also look at the confusion matrix. So I have my predicted class and my true class. And it looks like we want people who don't default on their loans. And we're not doing so great. So out of what, 1,500 people who did default on their loans, we caught 534 of them. So that's why our F1 score is so low. We're doing bad on predicting those true positives, but not as bad at predicting those true negatives. Okay. Another function that I really wish this had finished. Gosh, okay, that's sad. Because this, I think, is a neat feature. The evaluate model method. So if you have a tuned model and you run evaluate model, you're going to get a bunch of options you can pick. So again, one of the reasons I'm in love with PyCaret, up here, it may seem like, well, I've got to know what a confusion matrix is to even ask for it. I've got to know what feature importance is to even ask for it, and so forth. But if you just use this function or method, evaluate model on a tuned model, you can then click any of these. It's not going to work for me because I'm still waiting on some other code to execute, sadly. But you can click these, and it will switch to these different types of plots. So even if you don't know what kind of plot to ask for, you can say evaluate model on a tuned model, and then just start clicking around. And if one looks interesting and you don't know what it means, go Google it and learn about it. So you've got this vocabulary list that PyCaret has given you to go Google, to go look up on Wikipedia, or grab a copy of Elements of Statistical Learning, a great textbook, by the way, and figure out what these things mean. Here we've got the lift curve. If I don't know what it means, what is a lift curve? You could even say machine learning. There you go. Forge data science article, often some good stuff there. Okay, now the point is, PyCaret prevents you with these vocabulary lists along the way that you can figure out what they mean. You can go look them up. And even if you didn't know to ask for the learning curve, you can look at your learning curve. If you didn't know to ask for a confusion matrix, you can look at the confusion matrix. Has this finished? I'd really like to show you this working. Oh my goodness. Okay. We'll maybe come back to that because I think that's a cool thing to see, that I can just click between those curve types. Way back at the beginning in our environment setup, PyCaret split our data into a train and test set. Everything we've done so far has been on the train set. You may have been wondering about that. How is the cross-validation working? Is it giving me results on our test set? Is it training on a fold and testing on the held out from that fold? That's exactly what it's doing. Here at the end, we can say, all right, now give me the statistics using our test set. So PyCaret held out 30% of the data. And I could run predict model on my tuned model object. And using that 30% that PyCaret held out, we'll get our results. And it's lucky I ran these earlier because that other code is still executing. So these are my results on that 30% that PyCaret held out. If you remember, I actually held out 5% before that. So we can also make a prediction in just a second on the 5% of the data that I held out, which you might think of as like a validation set. If you are actually going to put this model somewhere where other people can use it, like a web app, PyCaret has this finalize model method that I think is pretty handy. So once you finalize a model, your object that it creates will take in data that looks like your input data and give you answers that looks like your target. So this is very much like a model that's almost ready for deployment. You can see what your finalized model looks like. So here are all the parameters set for it. You can get predictions from it. So I think this would just, again, be using our test set. And then I have my held out data. So I'll take my final model object, hand it that 5% of data that I held out back in section 5, and get predictions. So these are predictions on data that was not involved in any of the training. The model has never seen this data before, and we can get predictions on it. So this is sort of like a deployable model object. You'd have to have the PyCaret package installed on, say, a web server, but then you could save this model object through Pickle, which is the Python like compression library for saving Python objects. And you could get this model up on your web server, and just using the predict model method from PyCaret and this model object, you can give it new data to make predictions on. Okay. If you want to get a specific metric, there's a check metric method. So here you could say accuracy or whatever specific machine learning model metric you wanted to check, like F1, AUC, all of those words that PyCaret was throwing at us before. Oh, sorry, I was going the Pickle route, but I forgot PyCaret actually has a save model. So I can save the model, I can give it a name, and if we're really doing this, we would maybe assign it the date, save our model, and then we have this pipeline that is now a saved object that you can load somewhere else, and you can run your trained model again, like on a web server. If I want to load a model, here's the code. And sorry, I stopped running because we got stuck on tuning my random forest. But if I want to load my model, here's what I named it, load it up. And make a prediction, say, on data we've never seen before with that loaded model. There we go. Okay, so I want to pause there. Did this finish running? Just see if anybody has any questions, concerns, thoughts on life. Oh my gosh. We're still tuning that random forest model. I guess it's just collecting the results. It says it's done, but it's working on getting the results together. Okay, so that is the beginner tutorial on PyCaret. Almost exactly this tutorial is available in the PyCaret GitHub. Also, I've sent you the Google Drive folder. The next thing we're going to do is a more real world example. So what I mean by that is data that didn't just come from a PyCaret internal library, data that I had to go get somewhere and upload to Google Drive. So I'll show you how to do this on, quote, real data in just a second. But I'll pause there, maybe just for 30 seconds, see if anybody has a question. Okay, perfect. This is a quick check because I haven't actually seen anything in the chat from the break. Oh, okay, good. Someone's talking. Okay, I was just wondering there for a minute, like, did everybody leave? Did they hate it? Okay, so that was your beginner tutorial. What I'd like to do now is switch over to a real world example. It's fine. So it's upset because results aren't going to be saved. Okay, close some of this extra stuff we opened up along the way. All right. Inside the Google Drive folder, if you want to follow along with this next one, you'll see one called Near Real World Example. And because of the way we're going to do this, this may actually be a good opportunity to say, if you really want to be able to adjust things and save what you're adjusting, you may want to, within this folder that I sent out, and I'll tell you what, I'll send the link again because I know some people came in late. Everyone in meeting. Okay. Yeah, there's a strong chance that I sent a couple of those links just to Amy. That's why everybody was confused. All right, so there's the folder again. You may want to take a moment and actually copy this to your drive so you can make a copy of the folder. I thought it would ask me a question. So I've made a copy of that folder. Oh, that was of the file, wasn't it? All right, I want to make a copy of the folder. Let's see if I can remember how to do this in Google Drive. You know, I thought there was just a button for copying a folder in Google Drive. So if you guys click the arrow next to the folder name, I think instead of move to, you may have an option that's like make a copy. Or maybe you have move to and you can choose your drive. This is read only, so you shouldn't be able to miss anything I'm doing up. You may want to go ahead and make a copy of this folder. If you're not able to do that, you'll still be able to follow along, but some of the stuff you do might not be saved. Right click on the folder. Oh, then I've got to show you my whole drive. I didn't plan for that. Okay. Not that I think there's anything embarrassing there, but this is my personal drive, just the file. Oh, you can copy each file. What if I want to copy the whole folder? Anyway, I'm going to stop messing with that. It'll be fine. We'll still be able to follow along. So if you want to open up near real world example, worst case scenario, you could download this folder and re-upload it to Google Drive. Welcome to 2021. So if you wanted to, you could download this and then upload it to your own personal Google Drive, and that would get us there. Okay, so I have opened the file near real world example. And this is a good question to answer. What does the exclamation point do? So without an exclamation point, Python is interpreting this code. If I use an exclamation point, that means that I'm asking the terminal or bash or whatever your command line is if you were on a Windows machine to interpret this code. So this command would go straight to your operating system, whereas these commands are going to Python. So pip is something that you would run from the terminal. It's not a Python word, so you wouldn't use pip inside a Python script. Rather, you use pip in like bash or command prompt or PowerShell. And this is going to be a good test. So in our near real world example, I'm going to import PyCaret, and I think I'm going to have to run install again. Oh, let's see what happens. Yeah. So if I go up to runtime, we can see why this is happening. I do manage sessions. So I have 2 sessions running and they're separate. My binary classification tutorial is still running. And in fact, I am going to terminate it. If you have lots of sessions running, Google Colab will start yelling at you and say, I'm not going to run your code until you close your sessions. So close things that you don't need, similar to if you're used to using Jupyter, you need to close and halt the notebooks that you're not using. So right now, all I have running is my near real world example. And again, to get to that window, it's runtime, manage sessions. And it will show me all of my active sessions. Okay, so we'll need to do pip install PyCaret again for this real world example to work. And that's going to take a moment. So good time for questions, or if you're having trouble, anything like that. Okay. So what is it we're going to do while that's running? One, I'm going to make it so I can see all the code. So again, that's view, expand sections. I'm actually going to mount my Google Drive. So I'm going to make my Google Drive accessible via this Google Colab notebook. This relates to the question of how are we running all this on your Google Drive? We were just running it within a virtual machine, but now I'm actually going to connect Colab to the files in my Google Drive as soon as this other segment of code finishes. Okay. Once we've connected that, I'm going to use pandas, which is a Python library for handling data frames. And I'm going to use pandas to read in this data set. So before we just got it out of the PyCaret internal datasets library, but now this is just an Excel file that I have uploaded to my Google Drive inside the folder, demos for UAB Hackathon / and then the file is default of credit card clients. So it gets a little bit weird. If you mount your Google Drive, the path will start with content, drive, my drive. And then, let's say you have a folder called documents. Even though it looks like it's the top level in your Google Drive, you would still have all this stuff before it, content, drive, my drive. And then demos for UAB Hackathon is my folder, but you might have documents, you might have a folder called code, you might have a folder called Hackathon, you might have a folder called data. Did that finish running? Again, all we're looking for, collab mode enabled. You're going to be fine as long as you see this from running this first line in the near real world example notebook. So I ran this first line. I installed PyCaret on this virtual machine Google has lent me. I have brought in the enable collab method from PyCaret, and I have enabled collab. So this is specific to Google Colab notebooks. If you were running this on your local machine or on Chiha, you would not need these two. Just to point that out. Okay, on to the exciting stuff. So first off, I will mount my Google Drive. That's what this does. From Google Colab, import drive, and then drive.mount. I'm mounting my Google Drive. Okay, I think for pure account security, I will need to stop sharing screen in just a second. But the way this will work is once you click run, it's going to tell you to click this link. When you click this link, you might be asked to log into your Google account. You should do that. And then it's going to show you an authorization token that you're going to copy and paste right here and then hit enter. So just for account security purposes, I am going to stop share while I do that. But just to repeat, I'm going to click this link. I'm going to possibly log in with my Google account, and then I'm going to be given a token, just a long string of text that I'm going to paste here and hit enter. Okay, so again, I am going to scramble to find the stop share button and do this. And I'll narrate it as I'm doing it. So I'm clicking the link that Colab presented, and now it says, which account are you using? Because I have so many. So I will click the account related to the Google Drive that I want to use, which would be my personal one. And then I'm seeing a screen that says sign in, please copy this code, switch to your application and paste it there. And it even gives me a handy button that I can click to copy that code. It looks like two pieces of paper stacked on top of each other. Now I'm going back to my Colab notebook and I'm pasting that code and hitting enter. And now Google is thinking about it. And now it says mounted at content/drive. And now I will resume screen sharing. Okay, so if you have successfully mounted your Google Drive, you will get this note, mounted at /content/drive. Okay, and apologies that I can't demo that part, but just for pure account security reasons, I do not want to show my authentication tokens. Okay. So now I'm going to use pandas to import the same data set we used before. It's that default of credit card, but I'm not getting it out of PyCaret. I'm just reading it from an Excel file. Okay, done. I'm going to look at what the size is. And it actually looks like this data set was maybe updated since PyCaret copied it into their library, because we now have one, I think that's one more column and 6,000 more people that we know about their credit card data. I can use the .head command from pandas to look at the first few rows. If you've never used pandas before, this takes an argument. So if I wanted to look at the first 10 rows, I could look at the first 10. If I want to look at the first 2, I can look at the first 2. And by default, it is 5. Okay. I find it very handy often to actually look at what the column names are, because sometimes I'll want to copy and paste these places. So for example, earlier we just trusted that PyCaret was getting the categorical and numeric features correct. But if it weren't, what I would do is take the ones that are numeric, copy those, and make a list and just call it, say, numeric variables. So I think this is them. I might do something like numeric bars equals. And now I've got my list of numeric variables that I could give to PyCaret if it were guessing them incorrectly. Right, just like before, I'll do the thing where I hold out 5% of my data just for making predictions later, for really testing formally that we've done a good job. All right, and I will import. Again, I'm doing a classification task, so from pycaret.classification import everything. Yes, I'm polluting the global namespace for the Python snobs. I'm sorry, I'll keep doing it though. Right, okay, I got a little bit ahead of myself. So if PyCaret gets the categorical and numeric variables wrong, you know, where it showed you that list and you had to hit enter to say, yes, you got it right. You could come in here and specify them. So you could type them out just like I did up here. So let's do this the way I intended in my example. So from my numeric variables, I could paste them here. And then I like doing this trick where, let's say I know all of my numeric variables. I don't want to have to type both kinds. So what you could do, and I gave you an example here, is, I guess for the way I'm doing it, you can say categorical variables are everything that aren't numeric variables. And that's what this does. This is a Python list comprehension that says, I want you to give me every column for columns in the columns of X, which in this case, I don't think I called it X, I called it data set. Data set. If it's not in numeric variables. I might actually want to make an X. I see. That's what this note says. So don't use your response. So you could take out the default column. But we're not going to have to do that now. Just the point is, if you really needed to, you would make a list of all the categorical and numeric variables. And if you find that kind of boring and tedious, if you list all of one of kind, then you can use this handy model list comprehension to get all of the other kind. Okay. We don't actually need that here because PyCaret was doing a good job. But you can see here that if I wanted to specify my own, there are these two parameters, categorical features and numeric features, where I would give it the lists of my categorical variables and my numeric variables. And again, you see the power of breaking the 4 commas. All right. So this is a more real world example. This is how I would actually set this up if I was tasked, say, with figuring out who's going to default on their credit card payments, building a model that does that. Notice my setup command, much more complex than what we had in our beginner example. So I'm still using that same session ID, which will set our random state, so we'll all get the same answers. I want my train and test set to have the same distribution of responses. That's what this option does. So what do I mean by that? Let's say only 10% of people default on their loan. Well, I want 10% of my training set and 10% of my testing set to be people who default on their loan. This command data split stratify makes sure that your data is split for training and testing based on your distribution of responses. So you'll get an identical distribution across those two. Oh, okay. So someone's saying, I cannot, you're having trouble importing because you need to get that folder. Okay. See if we can figure this out real quick, because that is a little bit annoying, right? So David, since you asked the question, the worst way to do this is to download the folder and then re-upload it to your Google Drive. Okay, so this is happening for several people. That's frustrating. So what you could do is download the folder, re-upload it to your Google Drive. The other thing you could do is make a copy of the near real world example. So someone said earlier, right click, make a copy. That'll put that on your Google Drive. And then the data set is this Excel file. So you could right click on it, make a copy. Well, that's not helpful. So that put it in the folder for me, but it will put it somewhere else for you, ideally. And then you can adjust your path accordingly. Sorry about that. I guess I really banked on just being able to copy folders in Google Drive and didn't bother to test it before. So yeah, the worst case scenario, download the folder, re-upload it. The second worst, I guess, option is to make a copy of the example. So right click on it, make a copy, and make a copy of the data set. Even if you can't run it, I'll say the meat of what we're doing is this part right here, showing you some of the options that I set. Let me finish this, and then if we have a moment, I will go back and help folks who really want to run this on their drive. Okay, so just for the moment, though, I would say focus on what I'm showing you on the screen, because I think this is like an important tidbit to not be distracted from. So I'm setting these options here. I want my train and test set to have the same distribution of responses. So that's what this option is. I don't want to just take the average for missing numeric variables. In this case, we don't have any, but if I were doing this for real, I would use what's called the iterative method, where you take all of the data that you don't have any missings from and try to predict the variable that you have the least number of missings from. And then you take all of that and try to predict the next one. And then you wrap all that together and try to predict the next one. So you iteratively predict your missing variables. Because I'm going to try some non-tree-based methods like linear discriminant analysis and maybe support vector machines, let's go ahead and normalize the data. This will speed up some of those methods. If you're doing tree-based methods, this usually doesn't make a difference, though I have seen some people come up with pathological examples where it does. If you have some variables that are almost just all zeros or almost just all ones or almost just all the same number, you can do ignore low variance. I would put this in the maybe do this column, but these are going to be variables that aren't telling you a lot, and so they're sort of just wasting your time using them during training. And then finally, my data set is imbalanced, and most real world data sets are. That means that you might have 1% of people default and 99% not. So 99% of people pay their credit card bills and 1% don't. And so it would be very easy to just predict nobody misses credit card payments, and we're going to be right 99% of the time. So what we can do is rebalance our data set through some resampling methods. And in this case, PyCaret's going to use SMOTE, S-M-O-T-E, which it will show us when we do this setup. And again, if you want to know what SMOTE is, lots of good papers out there and Wikipedia articles. Okay, I'll let this run for a second, and then while it is running, I will try to help the people who actually want to do this and want to really play along. Okay, so again, it's showing me all of the variables and saying, I think these are numeric, I think these are categorical. I have to hit enter to tell it it's right, or if it's wrong, hit quit, and then go specify what's numeric and what's categorical. Okay, that's gonna, oh, that was faster than I expected. Usually when you set up some of the iterative stuff, it takes a second. Okay, so some people want to do this for real. If you've copied this over to your Google Drive and you have it in a folder somewhere, what you can do, if we go way back up at the top, you can mount your drive. And if you want to check that it works, you click this folder over here, and then under Drive, you'll see this new drop-down option of My Drive. And then start looking for wherever you saved that Excel file. And now you see my messy Google Drive. Okay. So for me, all of the stuff I'm using is in this folder, demos for UAB Hackathon. But when you made a copy, I imagine it put it somewhere else, or maybe it made a copy of this folder, in which case, fantastic. But you're going to find the path. And once you find the path to the folder you're looking for, so let's see, this would be for me, default of credit card clients. So notice I just sort of, through the graphical user interface over here, found the file I want. When you find the file you want, you can click the 3 dots next to it. Oh, and Zoom is messing me up. Let me move my Zoom windows. And hit copy path. So a couple people ask, what do I do now? Find the file, default of credit card clients, in this path. Copy path. And then in here in the pd.readExcel command, you can paste that path it gave you. So delete the one I have. All right, the Zoom window's messing me up just a little. Yeah. Okay, and that does need to be a string, so I'll put a quote at the start and a quote at the end. Okay, so the steps were, once you've got these files on your drive, mount your Google Drive using this line here. Then over here, under the folder icon, you'll see a drop down for drive. Go there. Then my drive, wherever you saved the thing. So for me here, find the file you want, 3 dots, and then copy path. And you paste that path it gave you in this pd.readExcel method as a string. Okay, I saw something pop up in chat, so let's see where folks are at. Oh, awesome. So at least one person got that to work, so I'm going to move forward as if that one person speaks for us all. Great teaching style, right? Okay, where did I get to? We have our environment set up. Again, if you're experiencing, and I think this is the most confusing part, if you're having this moment of like, this is running forever, what's going on? See if it's asking you the question. If they are correct, press enter. And at least in my experience, you have to go down here to this little box it gives you, click in the box, hit enter. And again, what it's doing is it's asking you to get the data types correct. And now let's look at a couple things in this, this vocabulary list it gives us. So notice I said I wanted iterative imputation. Imputation type is iterative. Whereas before, in our other example, it was simple. Normalize equals true. Normalize is true. Before it was false. Ignore low variance. And I have to find that one. Ignore low variance is true. I think by default it's false. Fix imbalance, true. Though I think that is true by default, so I don't think I did anything special there. But I do this explicitly. I really want to make sure that we're not just cheating by always giving whatever the most common answer is. Okay, so I've run that. I hit enter when it asked me, hey, are these data labels correct? Again, the most confusing, I think sometimes frustrating part. In this case, you can do a couple of things. So I don't really want to just look at what it thinks is the one best model, because these are default parameters. It's almost just like a random selection. Anyway, what I'm going to do is say who did the best with the default parameters, who was in the top 10. So I'm going to store my top 10 models. And again, I'm doing this as if I were actually like doing this for my job. I'm going to try to figure out who is defaulting on their credit cards. So what I did here was I said, I want to select 10. So in the compare models, before we didn't have an argument in that simple example. Now I've set the option nSelect equals 10. So I'm creating an object that's going to store the 10 best models. This is being much slower than when I practiced. Okay, the next thing I would do, if I were doing this for real, is I would use a package called scikit optimize, which PyCaret luckily plays very nice with. Oh, perfect. It's moving along. Okay, it's going to take a minute. If you want to do this, once your code up here is done executing, you can uncomment this line, pip install scikit optimize, and install this package called scikit optimized. Okay. The tune model command from PyCaret is happy to use scikit optimize. You just have to install it on your own. So now this is getting more complicated. Again, I said this is my real world example. So I'm going to tune all 10 of those models. And again, I'm going to do this in Python using what's called a list comprehension. So give me back a tuned model, and our iterator is going to be, or our index is I, sorry. This is our object that is one instance of our thing we're iterating over. I'm having trouble with my words today. So we're going to iterate through that list of the 10 best models using their defaults. we're going to run tune model, which is the PyCaret command, on each of those. So I is just like my model. Maybe if I said model, so that might be clear. So tune each model for the ones in the top 10. The default in PyCaret is to do it 10 times, so 10 tuning iterations. That's laughably small. I'm going to do it for 300. In real life, I often do this for 1,000. Sometimes I've done it for 10,000, though I think there's evidence that's excessive. So I would say like 300 to 1,000 using scikit optimize. Now, scikit optimize is a neat little package. It's going to do a Bayesian search. And I'm going to wave my hands around. So I'm going to stop the screen share for just a minute so you can watch me wave my hands around. So if you imagine we've got this big grid of parameters that we're going to search through, all of these possible things we can set, all of these possible hyperparameters. The analogy I like is all the knobs we can turn. And there's a big grid of them for whatever our model is. A Bayesian search is first going to just randomly sample your space. So maybe we'll get 20 samples throughout the space. And then it's going to use those 20 samples to locate sort of what are the best pockets of your parameter space. So, hey, 2 of our 20 random samples did really good. Let's now zoom into that area of our search space and just search around there. So now we'll just be searching around these places that did really well. Occasionally we'll bounce out of them just to make sure we haven't like gotten locked in a well. But that's a Bayesian search algorithm. So every time we test a model, we're going to remember how good that set of parameters did, and then search closer to it if it did well, search further away from it if it did poorly. So we're sort of updating our understanding of our model space and where the best models is with every step. And you can link that to like the Bayesian idea of, you know, our prior is sort of neutral or uninformative. We're going to assume the whole space is pretty good. We do that random sample. Now we have a posterior that's telling us, hey, these pockets of your space look really good. And then we'll sample closer to those, and we'll keep updating our probabilities on what the best corner of our space is. I get excited about Bayesian statistics. I also just happen to think this search method is cool. It is not like an exhaustive grid search. We're being a little smarter than that. We're searching the space a little bit, and then we're zooming in on the pockets that look good and searching those in a more fine-grained way. Man, this is being real slow. Okay, 2 of 10 done. If we ran this, we would get 10 optimized models where we tried 300 different points, updating, you know, our probabilities along the way and trying to zoom in on what the best part of our space is. We'd have the best out of 300 iterations on each of these model types. So that's 3,000 parameter sets we're going to try, right? Because we have 10 models. We're going to try 300 parameter sets for each one. That's 3,000. And we're doing stratified 10-fold cross-validation. So we really just trained and tested 30,000 models if we were to do this. Sometimes this is a thing that you let run overnight. If you don't mind troubleshooting, if you're like, okay, sure, I'm tech savvy, I'm good, I can handle the command line, I don't mind messing around for a while to make things work. I think the honestly best way to do this is with a package called Ray. If you want to install it, you would uncomment these 2 lines. You would install tune sklearn and raytune, and then again, scikit optimize if you didn't up here. And use this library called tune sklearn. The reason that I like this is coming from Ray, which if you want to go look up what Ray is from the company Anyscale. Ray will look at your computer, whether you're using your local computer or a machine on Chiha. It will look at whatever resources are available to you and figure out how to distribute all of your training tasks in an efficient way. So it will do this in a parallelized way, but it's a pretty smart parallelized way. So it's looking at all the resources you have and figuring out how to distribute all of the tasks that you need to do to tune these models. However, I find that raytune is a bit fussy. It will sometimes break. There are things that just, it's not installing as part of its dependencies that it really should be, and then you've got to track those down. So it's taken me on Chiha several hours to get raytune working the way I want and reliably. So if you're not afraid of troubleshooting, look up raytune, look up tune sklearn, look up Ray, and PyCaret is happy to play along with Ray. That's what this is doing. So I'm saying use tune sklearn from Ray to do my search of my parameters. If you don't want to mess around with that, scikit optimize works really well just out of the box, and these lines right here would be the way to go. Okay, again, if I were doing this for real, and this is taking too long to actually run, in my initial test, I found that a decision tree model was doing really well. So maybe I'll tune a decision tree model. And here are the parameters I would set. So I went and looked up decision tree models. I'm sort of modeling how I think you would do this. And these are the features that I think are important. And now I'm going to tune all of these features using that tune model command. All right, thanks for joining us. Sorry, you got to duck out a little early. That is really the biggest part that I wanted to show you today, is how to use PyCaret. We did not have time for our second choose your own adventure. I'll do one last demo with Chiha just so you can sort of see how it works. I am a big fan of PyCaret just because it sort of lets you grow. So if you have never done machine learning before, you're comfortable enough to click some buttons in Google Colab and maybe troubleshoot your way through getting your data files up to Google Colab. You can use PyCaret. In that setup command, it's showing you pretty much all of the settings that you could ever want to play with for those models. And then if you go look at the documentation and change what you're optimizing, maybe you don't want to optimize accuracy, you want to optimize F1 score. You can look up how to do that in the PyCaret documentation. There's a link to the PyCaret documentation in that first notebook. I think PyCaret is great because it's showing you all of these terms. It's not hiding them from you. You can look them up, you can change them. But if you don't know enough to change them, you're still going to get a pretty good result by tuning your model with PyCaret. It's going to do a pretty good job. The only thing I think you really need to worry about changing is set a higher number of iterations. By default, it only does 10. Give it a higher number. Let that search for a while. And if you really want to get fancy, install scikit optimize and let scikit optimize do a Bayesian search instead of just a grid search. So those would be the key parts. Use PyCaret. In tune model, set your iterations higher, maybe 300. And if you would like for that to be a really efficient search, install scikit optimize and just put that as your search library. So if you just wanted to tune one model, you don't have to tune 10 at once to use that. So search library equals scikit optimize, and I'm not following my own advice. Break before the commas, it'll change your life. And now this search for my decision tree model over 300 iterations would use a Bayesian search from the scikit optimize package. If you already knew what all those words meant, this may have not been the training for you, and I apologize. But hopefully you've learned a little bit with PyCaret. I often will just throw PyCaret at a problem as my first pass. So even if I'm gonna do everything myself in scikit learn, or if I'm going to end up doing something in TensorFlow, just as a first pass, I'll just let PyCaret try it. And sometimes you get a pretty good result. So even if you're experienced in machine learning, just try throwing PyCaret at some of your problems. It's like a 3-line solution. And sometimes we'll give you a model that's good enough. So that ends the PyCaret part. I do want to do just a brief how to use Chiha for this stuff demo, because I think that will be, if you're using a medical data set, if you don't have permission to upload it somewhere public, Google Drive isn't necessarily public, but really, if your data isn't public, you probably shouldn't Drive. Would be my rule of thumb there. If you know better, if you know what the right answer is for your data, that's fantastic. But as the rule of thumb, I would say public data, good on Google Drive. Non-public data, don't do it. And you can take the risks accordingly if you go against that advice. I've left some other notebooks in here. I was hoping we would get to this one called Houses, Text, and Images. So this actually goes outside of the realm of PyCaret, and this demo shows you how to train a TensorFlow model, or rather Keras. So I think this demo was built when they were still completely separate things. Now they've sort of melded into one thing. But it shows you how to use Keras to actually train a model on images. And if you want to follow along, you could run all of this and look through it. Also, if you just sort of Google the houses and images, trying to get the words right. Houses, text, and images, Keras. You'll find someone who's actually put together a 3-part demo using this code. I think I've modified it very little from their demo. So the houses, text, and images demo is on the internet. It's on GitHub. In fact, I think this particular GitHub may have the full demo. So if you want to use something like radiological images for the AI Against Cancer Hackathon, this might be the demo for you. I apologize we didn't get to it. I thought that might happen, which is also why I stole all these demos from elsewhere, so that you can go find them and look at the full tutorials that other people have put up. But this would give you the framework for if you wanted to train a model based on images, say, or text in images. This actually does some tabular data telling you details of the house, like its square footage, number of bedrooms, bathrooms, that kind of thing. And then actual images of the house, and trains a model to predict their sell prices is what this does. So if you want to play around with that, that can be fun, especially if you're trying to do something with images. And that would actually be a case for using a GPU. So if you want to use a GPU in Google Colab, runtime, change runtime type, and you choose GPU. I think I already set this notebook up to do that by default. But then you will actually be using a GPU. So TensorFlow will be running on a GPU. It has lots of GPU optimizations. If you're not training a model with images, the overhead for GPUs is almost never worth it, in my experience. And so you'll do better just leaving your runtime type as the default, which is none. So no GPU, unless you're using images, there's really often not a point, and it will sometimes even go slower than just running on the CPU, I found. Okay, so the last thing I want to do is just a quick, I promise you can make this work on Chiha, and I'm going to do that real fast. So it might be lightning speed because I want to respect folks' time and try to end on time. So let me log into my on-campus machine. Okay, in the pre-work, I sent out a link to a PDF that I'll post in chat now. If you've never used a GPU on Chiha, these are the instructions for getting started. And what we'll do, share my remote desktop. So these are the instructions. Go through these, and once you've gone through them, it talks about steps you have to do the first time and steps you have to do every time. One of the things you'll do is request a GPU node, and you really should use exactly this command, chain parts, so your job name and your time, which you can increase up to 12. I think you can't go over 12. If you have a task that runs more than 12, you're going to have to learn about checkpointing and then break this up into 12-hour tasks. I would recommend, if you're on Windows, using a program called MOBA Extern. It is both a FTP server, so I've got my documents here on the left, and an SSH client, so like PuTTY. I've connected to Chiha. I've run that command to request resources, and I've gotten them. So I did that early this morning just to make sure we wouldn't sit around waiting on resources. But I've done nothing else. So I have gone through the setup steps before, so I only now need to do the every time steps. And so, for example, as you read this, you'll find step 4 is an every time step. So I'm going to do module load Anaconda. So this is going to load, oops, this is going to load my Python environment. I'm using the Anaconda package manager. I'm going to activate this Conda environment, which is really just a set of Python packages that the instructions tell you how to set up. So everybody has to do this separately. There's not like one that's just there for everyone to use. So that would be my own Conda environment that's called deep. And that's going to miss an M, isn't it? And then I've got to run this command to load CUDA, which is for using GPUs. All right. And then I have to do this line. We're almost there. We might go 1 minute over. Okay, so this line here, and again, I would say, open up this PDF every time you're going to use a GPU on Chiha. You're going to forget this step right here, and then things won't work. I know because I've done that. I've gotten really frustrated, just banging my head against the wall. And then I go back to the instructions, just like I advise other people to. I'm like, oh yeah, I got to run that line. So what we're getting to is we're going to end up with a Jupyter Notebook environment on Chiha. People who use Chiha might say, wait, there's like a button on the website, right? For me, the GPUs don't work quite right when I go use the button on the website. So I do go through these steps every time I want to use the GPU. All right, so now I'll get a link that looks like this. That says, this is where it's running. And it really seems like I should just be able to like copy this into my browser. But you're gonna have to do one more step. You've got to do port forwarding. And I bet a lot of people just like rolled their eyes and like, oh, too complicated. It might be, that's a choice you can make for yourself. If you're using MOBA Xterm like I am, this is really helpful. So the first time you do this, you'll click a button that says new SSH tunnel. I'm gonna click a different button because I've done this before, but you'll click new SSH tunnel. Oops. And then this would come up for you. And now I've just got to enter all this information in the right place. So what I'll do is just, I'm going to read from left to right, and you almost just do it in that order. So this is telling me that the machine I'm using on Chiha is C0113. And so I'm going to put that right here. If you don't have MOBA Xterm, or you forget this, those written instructions I gave you tell you how to do this in PuTTY, which is the typical Windows SSH client. So I'm going to use port 888 because that is what is being used right here. I'm going to put in my login information. So you're going to log into chiha.rc.uab.edu. This is in the written document. You don't have to scramble to write that down now. I will use my Chiha login name. On Chiha, the SSH port is 22, so you'll put 22 right here. And then whatever I want the port on my local machine to be, so just to prevent confusion, generally match these two up, and then you won't get lost. Again, this is in the written instructions for PuTTY. I like MOBA Xterm because it gives me this nice little graphical window. All right, I hit run. And now, through the magic of live coding demos, this probably won't work. Yeah. So I did something wrong in my tunnel setup. Let's see if I can find it real quick. Extra 0, that will do it. Save, stop this, run it again. And there we go. So now I'm connected to this machine on Chiha that is giving me GPUs, and it is now asking me for my security token, which I probably shouldn't be showing you. But I will paste that right here. And now I have access to my Chiha files. These files are in the Google Drive as well, so don't get freaked out there. If you want to try to run that PyCaret demo that we did on Chiha, you can upload it to Chiha and run it. If you want to do the houses, text, and images where you're actually using TensorFlow and GPU to train things, that's in here, and you can run it there. All right, I'm so sorry. We went, what, 3 minutes over? I apologize, but there we go. That is your demo on how to use PyCaret, which again, grows with you, big fan. And then I pointed you toward, but didn't get to run through the demo on how to actually do deep learning with TensorFlow, both on Google Colab and Chiha if you want. So I can stick around for a few more minutes, but I know we're at time. If people want to ask questions or ask general advice, I'll stick around for just a little bit for that. And thanks everybody for your attention.
Yeah, thanks very much. That was really great. I think I'm going to have to watch the recording and go back and try some other things myself. But yeah, thank you very much. That was, you know, I don't know how anybody could have done that much content in one session like that. But thank you. And I think that's for our hackathon. And be sure to join us next week. Same bad time, same bad channel. Jake is going to give a lecture on AI advances in cancer, and also that'll be followed by a UBright boot camp. So it'll be a boot camp having to do with our data commons. All right. Have a good weekend, everybody. Okay.
Thanks.